Hello, my name is Omar and I'm representing my group consisting of Keian, Castro, Brandon Visitacion, William Lee, and in this presentation we will go through the steps we took to create and design our product. And in today's times, COVID has caused unprecedented issues, and basic bottles like squeeze and pump bottles require physical touch to exert fluid, and as well as basic hand sanitizer dispensers where you have to push, dispense, or put your hand under in which contact could happen. This leaves room for infection. And so we want to identify a solution in which we can combat that problem. This is the proposed final mechanism and product, which will give you insight on what my group members will be talking in depth about. It shows the mechanism as well as the functionality and what is the purpose of it.
For the linkage synthesis of both crank slider mechanisms, we focused on having the mechanism operate within a certain criterion. This included dispensing a reasonable amount of hand sanitizer, having an actuation time of 2 seconds or less, and being compact as possible for easier transport. One thing we had to keep in mind was the limitations that come with the manufacturing. We determined the shortest link to be no less than 1 centimeter to prevent manufacturing problems that would lead to mechanical failure of our mechanism. For the quick forward mechanism, we wanted the time ratio to be 2 to 1. This time ratio was randomly selected with the intent of increasing the acceleration of the slider while also decreasing the time of contact it makes with the nozzle of the pump bottle. If the same force was exerted on the nozzle in 2 different scenarios, the shorter contact period will generate more applied force. And for the normal crank slider compressing the squeeze bottle, the link lengths were established based on the fact that we needed the squeeze bottle to be displaced by 8 millimeters to eject a reasonable amount of liquid. The drawings were remade in SOLIDWORKS to check whether they would meet the given requirements.
The equations derived from the general crank slider schematic were utilized within MATLAB to provide position, velocity, and acceleration results for both of our mechanisms. In our case, we were mainly focused on the position and acceleration analysis results in order to confirm that our linkage synthesis satisfied our displacement constraints and to determine the maximum values of acceleration, as those values will be affecting our mechanism's ability to apply load. Based on our MATLAB analysis, we can see that the maximum displacement and acceleration for our quick forward mechanism satisfy our preliminary conditions. And similarly, we could see that our results for the position and acceleration analysis of the regular crank slider mechanism show that they do satisfy our preliminary conditions as well. For our force analysis, we needed to derive a matrix that represented the forces and moments that our mechanism will be feeling during its function. For the regular quick forward variation, we can see that the maximum torque required by the motor is significantly below the maximum motor torque output. And similarly, for our regular crank slider mechanism, we can see that the maximum motor torque output constraint is satisfied. For our force analysis, we can find that the most critical point on our mechanisms will be at the joint between the motor shaft and motor sidewall, as the bending stress moments will feel the maximum moment arms at that location. For the quick forward mechanism, we find that the factor of safety is 39.676. When looking at the same critical point for the regular crank slider mechanism, we find that the factor of safety for this one is 32.390, and since it's the lowest factor of safety between the two mechanisms, it will be utilized as a factor of safety for the overall mechanism, and we can ultimately say that our overall design is safe.
This is the full construction of the hand sanitizer dispenser box. This is the motor control, which controls the sensor and the motor, and on the side we have the door, which allows access to the inside of the hand sanitizer box, so you can load the hand sanitizer cartridge, and it has a lock to secure the cartridge inside. And in order to load the hand sanitizer, you need the cartridge along with hand sanitizer, the mini hand sanitizer choice. You place inside the hand sanitizer dispenser, lock the door, and start up the code. And once the ultrasonic sensor detects a hand, it should dispense hand sanitizer. Just like that.